In this session of management decision tools, we will discuss more about linear programming applications by examining another example in the financial application area. Financial applications can involve many situations, such as budgeting the money that we have or the company is given, make or buy decisions, uh, allocating assets in terms of money, cash, bonds, uh, real estate, and so on. Portfolio selection. How many shares of stock A, B, C should I have? Things like that. Financial planning in terms of how much money I need now in my youth. 10 years later, how much money do I need to have a family, to grow the kids and retire? And that's financial planning and more. So all these involving money will also involve time because time is money. So in this example, we will also try to learn another model-oriented trick. That is, how do we tell LP model about time? Now, if you recall, our LP model has four sections: decision variables, objective function, constraints, regular constraints, and other constraints. In regular constraints, it might be very tempting for us to say that if we write the constraint first, it is being satisfied first somehow. But that's not true because the order of the constraints doesn't matter. So in other words, there is no sequencing, there's no orderliness of anything that we can tell or inform our model about real time, right? So like this year we need 10,000, but next year we need 20,000. How do I tell the model that about the time progress, right? So that's a trick that we want to learn, and it's easiest just to work through an example to see how it's being done. So here we have a fund manager's scenario, but while that may be sounding uh, um, totally out of your line of work or out of your interest, and we may not have $20 million, or maybe you have, but it can always be applied to our uh, day-to-day scenarios, right? Our division, department, project scenarios, our personal scenarios, where we may replace this with $2,000, with $20,000, with $200,000, right? So these are just how do we allocate the funds that we have in a optimal manner. And by optimal, even though it is having more money for sure, there are also a few ways to describe optimality. Is it to have um, the highest amount of final amount of cash, or to have the highest amount of cash flow per season, per accounting period? Or so there are different ways to talk about uh, a lot of money. Certainly with respect to time, there are different time milestones, right? So we have to be clear what we really want in terms of financial planning and goals required. All right, so here in this scenario, the fund manager has $20 million at the start. Okay, at the start of the time of investment. It wishes to invest over the next 4 months. How do we tell the model that it is 4 months? In such a way that it will maximize the total accrued interest. Accrued here means that the moment you have invested the amount, the interest is already yours, considered yours, even though you haven't received them already. It's considered yours because legally it's legal binding, so the interest is due to you, but you cannot get it until the investment horizon has lapsed. So accrued means we wish to maximize, right? The fund manager here wishes to maximize the total amount of interest that is immediately considered yours, that is accrued to you the moment you have invested. See, when you invest, it takes time to mature, then comes back with interest, right? But if this investment is legally assuring you, as is the case of a loan, legally assuring you of the interest that you'll be getting, then accrued interest simply means that you can count that as yours. So Of course, in real life, accrued interest has the risk of not being realized, right? Because the company may go bankrupt, may run away, may not return purposely, intentionally. Whatever is the risk, that's the risk part. But is by law, is the interest due to the investor, this Winslow savings? Answer is yes. And do you want to always optimize, maximize the accrued interest? No. All right, that's the choice made here. They want to count the money even when it's not in the hands. All right, and that's okay. That's okay. In the sort of peaceful times, without upturns and downturns and economic crisis, that's pretty safe way of maximizing your longer term returns. Right. So here the decided uh, objective function is the accrued interest earned over the 4-month period. So Winslow Savings, the fund manager, has this 4-month planning scenario. Um, at least 10 million should be available at the start of the 5th month. The word start comes at the right time when I want to actually emphasize the use of this word in decision variables whenever it involves time. Very important. Reason is that we have 4 months. If we are here now, we have 1, 2, 3, 4. And it's not because it's month and it's so long. It can be a day where your decision is to be made every hour. So you have to make 24 decisions in a day. And that's very, very long for one day as well. So we have 4 months and the fund manager has to make decisions every month, right? So if you invest at the start of the first month, right, then you have 1 month to mature and you get interest here, right? So it is important in time related, investment related problems to be very clear about when you put your money down. When you put your money down. And the easiest, should the question permit, and it is permitting us here, is to state that it is at the start of the month. It could be that it is the end of the month, but doesn't matter because let's write that down. End of the month is the same as the start of the month. The previous end of the previous month is the same as the start of the next month in this kind of problems. So let's write down the 2 pointers here. Must, all right, must, I use must, all right. The must include start in decision variables involving time. If it's not start and it's the middle or the 10th of the month, then do so. So that it's clear, right? So that our counting of the days will be clear. And if the question permits, then just use start. What if the question requires us to use the end? Well, then the next bullet point comes in. The end of previous month or the previous duration is equal to the start of next month, right? So that we can just consistently use the word start in decision variable, and that should be clear. So the only other variation might be the middle, right? And otherwise, those in the 3 quarters, just try to approximate it by rounding them to the start of the previous month or the next month. So these are the 2 important pointers to keep in mind so that the manner that we think about time and porting it over to the model is simplified. Okay, so when you say at the start, means that we can at the end of that month count our interest, our money, right? Because we'll be getting it back within a month if that's the case. And then we will have to make another decision again at the start of the 2nd month. How much should we invest in which one? How much should we invest in which one? How much should we invest in which one? Which investment vehicle? How many vehicles do we have? In this case, we have 3 investment vehicles. We have one choice is a 2-month long government bond giving us 2%. So in other words, you put in $100 at the start of the 2 month, and after 2 months you will collect $102, 2%. So in the middle you cannot take back your money. In the middle you don't get your interest, not $1. Okay. There are other bonds structured in different ways where some of these monies can be available, like partial return of the investment, or some sort of partial payment of interest or payment of interest for that time period. And that's really up to the structuring of the bond or the loan, right? But in general, it is going to be much more complicated to count down to the last day of return of the money and changing interest rates and all that stuff. Here we simplify everything, right? So you don't get your principal nor interest back until the end of the investment time horizon. Another choice will be the construction loan that will last for 3 months, but giving higher interest rates, 6%. Again, for simplicity, you don't get back anything until the end of the 3 months. Finally, the third choice is a manner or the highlighting of no choice. That is, if you park the money there in the bank as liquid, then you'll be getting 0.75%. Right. So in that case, 0.75% is not much, but at least it's not zero, and that is to discourage you from not investing the money. So here we have 0.75%. Formulate a linear program that will help Winslow Savings, the fund manager, determine how to invest over the next 4 months.